Python pals, it's Prof G, and in this lesson we're going to be working in an area of Python called the REPL. It's a sort of scratchpad that lets us execute code line by line. It can be really useful for testing things out on your board, so let's learn big. We're going to be working with NeoPixels in this lesson. I've plugged in my CircuitPlayground, open PyCharm, let's go into the terminal and launch TO. Since that was the last command I'd entered, I can up arrow and press return, and TO is running. Remember, this shows you all of the output for code executing on your board. Now, the last code that I had on my board is executing on my board. This was the infinite rainbow flash from the prior lesson, but if I want to interrupt this executing code, I can enter Control-C, that's the break character, and if we scroll up, we can see this line where our code was interrupted, but down here we also see this message, press any key to enter the REPL. Use Control-D to reload. So make sure that you remember Control-D, because that will get us out of the REPL. But let's press any key to get in the REPL, and we see three greater than symbols, or chevrons. That's the REPL prompt. Now, if your board has any NeoPixel lights on them, when you enter the REPL, you see those three chevrons, all the NeoPixel lights on the board will turn white. So pro tip, if you ever look at your board and you wonder why your code isn't executing and any NeoPixel lights on the board are all white, it's because you're in the REPL and you need to leave before your code runs again, so just press Control-D. Now, we also see this message stating our CircuitPython version and our board. My board is the CircuitPlayground Bluefruit, and it says NRF528040. That's the microprocessor on the board, or the brain on the board. Now, in the way that most Windows computers use Intel chips and most Macs use Apple Silicon, the M-class chips, the CPB uses a chip by the Nordic Semiconductor Company. Geek knowledge drop. These chips are actually based on a core technology from a company called ARM or ARM, and ARM technology is baked into just about every smartphone on the planet, including most Android phones, all iPhones, and ARM technology is even in the M-class Mac chips. Now back to the REPL, which is an area where we can execute Python code line by line or in small blocks. Most programmers use the REPL as a sort of scratch pad. Most Python environments, even those outside of CircuitPython, usually include some sort of REPL, and REPL stands for read, evaluate, print loop. That means that the REPL will read in any command entered, evaluate it, print the results, and then loop back so that it can start to read the next statement that was entered. So let's try that out. Let's enter a print statement, print, in double quotes, you are awesome. Unfortunately, in the REPL, you've got to close your double quote and your parenthesis. It doesn't do the automatic typing help that you get within PyCharm, but when you press return, the computer confirms with its output that you are indeed awesome. Now, we can also enter simple calculations and see the results. So, for example, when you hear the term 8-bit, as in the color system that we use is the 8-bit RGB system, each bit is a 0 or a 1, so an 8-bit value is 2 to the 8th. If we want to calculate that, we can say 2 ** 8. That double star means take the value to the power of 8. Then press return. That's 256, which is why each of our RGB values can be from 0 to 255. You can put that value in a variable like color_size equals 2 ** 8. And by the way, there are a few shortcuts we can use in the REPL too. So if you type the first few letters and then the tab key, the REPL will try to fill this in. So let's try this out. If we want to figure out how many total colors we can represent in the 8-bit RGB color system, we can say CO and then press tab, and oh, look at that. The REPL enters color size, so then I'll say ** 3 so that we get color size multiplied by itself 3 times. Press return, and we see the result is over 16 million colors can theoretically be expressed from the 8-bit RGB color system. Cool. Now, we still have our Python editor up above, and if we make any changes in this code above and we save them, those changes are not going to execute. You've got to first leave the REPL. Another thing to be aware of is once you leave the REPL, it forgets everything that was entered during that session. Let's leave the REPL right now. Now, one really important thing to remember, if you're entering commands that should execute in the terminal, make sure you've clicked on the terminal first. When your terminal is active, you'll see the terminal icon highlighted like it is here. And let me show you why this is important. If instead I click up here in my code editor where code.py is, then press Control-D, then a PyCharm shortcut is executed. In this case, it brings up the debug pane. See how that little bug icon is highlighted? And that's on top of where my terminal was. If this happens to you, don't worry. You can always get back into the terminal by clicking that terminal icon again. Then your terminal is active, and whatever you type now will go to the terminal. It won't be considered a PyCharm shortcut. So now that I'm sure terminal is active, I'm going to type Control-D. The next line shows that I no longer have those 3 chevrons of the REPL prompt. All of a sudden, any code saved on the board will start executing. So to get back in the REPL, we first need to stop our code execution with Control-C. Then we can type any key, get into the REPL, and we see the NeoPixel lights turn white again. And to show you the REPL forgot everything, if I try to do color_size here and press return, the REPL says that it's not defined. When we left the REPL, it forgot everything from the previous session. Now we can enter any code we want in the REPL, but just like our code.py file, we need to import any libraries we want to use before those libraries will work. For example, I can copy the line creating the pixels object it from my Python code up above and then paste it in the REPL, but I'll see lowercase NeoPixel is not defined. So as a programmer, you want to pay attention to any errors that show up and see if you can Sherlock out the reason why things didn't work. By saying NeoPixel is not defined, it means I don't know about this thing called lowercase NeoPixel. How come that occurred? Oh, we didn't import the NeoPixel library. So I'm going to copy the entire NeoPixel line here, paste it down below, then I can paste in my pixels line, or even better, the up arrow trick works in the REPL as well. Each up arrow will show you the last command that was entered in the REPL. Of course, it forgets about all of the commands that were entered in the REPL when you get rid of the REPL session, but I've got pixels up here. I can press return. That's kind of nice. I don't have to retype it. And so now here's a quick challenge for you. We see all of the lights are on in white. What command would you enter to turn off all of those lights? Why don't you pause, give it a shot, unpause when you're ready, and the command is simply pixels.fill 2 parens 0, 0, 0, and 2 closing parens. Type that in, press return, and the lights go off. Now, if you couldn't answer that question, don't feel too bad, but this is an indication that you might need to focus more on the learning in each lesson, because commands like this are going to be really important when you start working on your own projects. Now, another thing we can do in the REPL is we can copy and paste multiple lines. For example, I'm going to copy and paste all of the colors that I created in the code above, and I'll paste them below. All those colors are now entered. I can refer to them in my code. So if I say pixels.fill in parentheses, all caps violet, I can see all the NeoPixel lights on my board turn violet. Cool. Now, one of the ways the REPL can be handy is if you want to experiment with colors without having to write and run an entire program. For example, the university where I teach, Boston College, has school colors maroon and gold. Now, unfortunately, not all colors are easy to represent with the inexpensive LED lights that are on our CircuitPlayground. If I search online, one site says that maroon is 12800, so I can try pixels.fill, double paren, 128, 0, close double paren, and it still looks kind of close to red. If you want to compare, you can say pixels.fill and in parens capital red, and I can see this, and remember, the REPL remembers the prior command, so I can press the up arrow twice and compare that with the maroon, and yeah, I'm not too happy with those results. Now, I fooled around and experimented with different values. I tried 80 for red, then 40 for red. Pixels.fill, 40, 0, 0 was alright, not super great, but certainly better than straight up red, so I'll create a variable all caps maroon equals, and in parens, 40, 0, 0. Now, our other university color is gold. So I searched online. One site suggested gold was 212, 175, 55. So if I try pixels.fill, double parens that value, it's too white. Now remember, orange was pixels.fill, double paren, 255, 40, 0. I messed around with some of the values, and I thought 255, 60, 0 looked good. So I'm going to create the variable gold equals, and in parens, 255, 60, 0. Now, you can also enter loops in the REPL. Let me show you. Let's create some code so that the board flashes, alternating my school colors every second. So I can enter while space with a capital T, true, colon, and when I press return, I see that the next line is indented, and I also see 3 ellipses instead of the 3 chevrons. This lets me enter the body of the loop. So I'm going to enter pixels.fill and in parentheses maroon, all caps, then press return. I'm still indented. Time.sleep and in parens 1.0. Then on the next line, pixels.fill in parens gold. And I'll close this loop with another time sleep passing in 1.0. Now, how do you get out of the indent? Press the delete key. And from here, a return should execute the loop, and you should see the changes happening on your CPB. Cool. And if you want to stop that code from executing, just type Control-C again. By the way, sometimes I've found that I've gotten stuck in the body of the while true for some reason. Even after pressing delete on a new line, it wouldn't execute. But if you Control-C, you should be able to get back so that you can start fresh. So that's the REPL. You're armed to experiment with some code, using the REPL as a scratch pad without having to write an entire program and run it. Nice! The REPL is quite handy. We'll use it in future lessons, including in our next lesson when we'll experiment with Python sequences and learn how to manipulate each individual light one by one. Until then, continue to hack.